Okay, in this problem, it says a recent local musical sold adult and child price tickets for admission. They sold a total of 68 tickets for the Saturday matinee. The adult tickets were $18.50, and the tickets and the a child ticket is $7.50. If the number of adults, so part A says, if the number of adult tickets they sold is represented by A, so they told us what A represents, the number of adult tickets. So A represents the number of adult tickets. Okay, so it asks us to write an expression that we could use to find out the number of children's tickets. So we don't know how many children's tickets there are. So let's think about this a little bit. If there are a total of 68 tickets we are told that are sold, let's just say one adult ticket is sold. That means the rest of them are children's tickets. So the rest of them, that would make 70 or 67 children's tickets if there's one adult. So let's say that there are 5 adult tickets. Then if there's a total of 68, 68 minus 5 would be 63 children's tickets. And let's say there are, 10 adult tickets. That would make 53 children's tickets. So if we take the number of adult tickets and we subtract the number of adult tickets from 68, so if we take this 1 right here, 68 minus 1 is 67. If we had 5 adult tickets, 68 minus 5 is 63. That's how we would get that number there. So our expression that we could use to figure out these numbers here in this column is 68 minus A. So the number of children's tickets is going to be represented by 68 minus A. So that is part A. Okay, then part B says the total amount collected for all the tickets was $708. Write and solve an equation that can be solved to find the number of child tickets and the number of adult tickets that were sold. Okay, so if we go back to the original problem here, the top of the problem, it says that an adult ticket is $18.50. So each adult ticket, $18.50, each one, $18.50. So if we add up all these 1850s, that tells you how much was made from adult tickets. But the problem is we don't know how many adult tickets. That's A. We also know that repeated addition is the same thing as multiplication. So if we take 1850 multiplied by A, since A is the number of adult tickets and we don't know how many there are, this represents the cost of the adult tickets. So we have 1850A plus, now we have to add the cost of the children's tickets. And if we go back, it tells us that a child's ticket was $7.50. So that means each of these tickets is $7.50 plus $7.50. Each one is $7.50. Well, adding $7.50 over and over again is the same thing as multiplication. So we're going to take the number of children's tickets, which is 68 minus A. So this is the number of tickets, and we're going to multiply it by the cost of the tickets, which was $7.50 here. So $7.50. So we're going to add on $7.50 per child's ticket. And the problem tells us that the total is $708 altogether. So now we have our equation, and now we can do the next part. Solve the equation to find the number of adult tickets. Okay, so we have our equation to solve. First thing we're going to do is go ahead and distribute. Okay, so we distribute 7.50 to the 68 and multiply, and then we multiply to the negative 1a, and then we get this. Next thing we're going to do is go ahead and combine our like terms, continue simplifying. So those both have a's in the term, so we're going to combine them. 18.5 minus 7.5, that's 11a. And now I have one variable term, so now I can take away the 510. And then the last step, when our variable term is isolated, that is when we divide by the coefficient of the a. And we get that there are 18 adult tickets. So if we go back to our original problem here, it tells us that a, which we just got, was 18. And then here, that if there's 18 adult tickets, now we know that there are 68, because there's a total of 68 tickets. Take away the adult tickets, that leaves us with 50 children's tickets. So the number of adult tickets is 18, and the number of children's tickets is 50.